Alright, here's solutions to quiz 6 from Math 251. We're told there's some function f of x, not even given the function, turns out you don't need it. But what we do need is its derivative, and supposedly its derivative is this thing right here. So some function defined everywhere, that's key, and its derivative is this thing. Find the critical values. Critical values happen in two different cases. Happens when the derivative equals 0, or when the derivative is undefined. Assuming that the function is defined, but it tells us the function is defined everywhere. So basically we need to look at this thing and figure out when it equals 0. It equals 0 when the numerator in this fraction equals 0, x squared minus 5x plus 6 equals 0. Probably the easiest way to figure that out is to factor and get x equals 2 or x equals 3. So the derivative equals 0 when x equals 2 or when x equals 3. So we have critical values at both of those points. We can also figure out when it's undefined. It's undefined if we divide by 0. We divide by 0 if x minus 1 were equal to 0. In other words, if x were equal to 1. Critical values when x equals 1, 2, or 3. Alright, take the smallest number that was an answer to part A, x equals 1. And classify it as either a local min, local max, or neither using the first derivative test. Alright, so for the first derivative test, what you have to do is look at this thing and figure out if it's changing at x equals 1, if it's changing from negative 1 to positive 1, if it's changing from negative to positive, or if it's changing from positive to negative. I think the easiest way to figure it out is look at the factored form of your derivative. In other words, look at x minus 2 times x minus 3 over x minus 1. And then if x is less than 1, really what we're looking for is the limit of this derivative as x approaches 1 from the negative side. Maybe I'll write that. Sure, why not? Limit as x approaches 1 from the negative side of this derivative. Well, let's see, if I'm slightly less than 1 and then I subtract 2 more, it's a negative number. If I'm slightly less than 1 and I subtract 3 more, that's a negative number. If I'm slightly less than 1, so 0.9999, and I subtract 1, that's a negative number, just barely, but it's a negative number. A negative times a negative is a positive number. Positive divided by a negative is a negative. What we get is that this limit is a negative number. I don't know what the number is. I don't need to know what it is, just that it's negative. The limit as x approaches 1 from the positive side of this derivative will be similar. Positive 1, a little bit more than 1 minus 2 is a negative number. A little bit more than 1 minus 3 is a negative number. A little bit more than 1 minus 1 is a positive number, just barely, but it's positive. So this is positive. So x equals 1. Let's see, the derivative to the left of it is a negative number. The slope is negative, is going down. The derivative to the right is positive, so it's going up. It switched from going down to going up. So x equals 1 is a local min. Classify any remaining answers, x equals 2 and x equals 3, to part A, as either a local min or a local max using the second derivative test. Alright, for the second derivative test, we'll need to know the second derivative. We know the first derivative. You can use any form of it you want. I'll probably just use the one that's given. If I want to know the second derivative, I'll have to use the quotient rule. The derivative of the top is 2x minus 5. Leave the bottom alone, x minus 1. From that you want to subtract the derivative of the bottom, which is just 1, times, leave the top alone, x squared minus 5x plus 6. And then that whole thing you want to divide by the bottom, x minus 1 squared. When the dust kind of settles here, 2x minus 5 times x minus 1 is 2x squared, but minus 5x minus 2x plus 5. And then I want to subtract this whole thing, so I got minus x squared plus 5x minus 6. That's all divided by x minus 1 squared. So what I have up top is 2x squared minus x squared. I got just x squared left over. Negative 5x minus 2 more x is negative 7x. Plus 5x leaves me at negative 2x. And then I got a plus 5 and a minus 6, so I get a minus 1 here. And I want to divide that by x minus 1 squared. This right here is one way you could write the second derivative. When you have the second derivative, what we got to figure out is if this second derivative, f double prime of 2, is a negative number or a positive number. If you plug in 2 here, you'll get 4 minus 2 times 2 is 4 minus 1 divided by 2 minus 1, which is 1 squared. You'll get negative 1. How about that? Cut out some steps. So what that tells you is that it's concave down at x equals 2. The slope is 0 because the first derivative was equal to 0 at x equals 2. So the slope is 0, it's flat, but it's also concave down. If the slope is 0 and it's concave down, that means we have a local max. Similarly, f double prime of, what was my other one, 3? See, 3 squared is 9, minus 2 times 3, which is 6, minus 1, divided by 3 minus 1 squared, which is 2 squared. It's going to give me a positive number. Right, this is a positive over a positive. 9 minus 6 is 3, minus 1 is 2. Ends up being positive 1/2, but really it doesn't matter what it's equal to, it just matters that it's greater than 0. So 3, maybe x equals 3, is a local min. If it's concave up and the slope is 0, then what we have is a local minimum. Alright, second problem. That was a long first problem. Suppose I invented a unit of length called a Bryan. Oh, this is the baseball problem. So what's going on here is here's first base, here's second base. The distance between all the bases is 4. So this is 4 here. And I have this guy running towards first base, and he is 3 Bryans from first base. So he's somewhere in here. This length is 3. And this is the distance from second base. This is kind of a D out here. So the way to figure this out is if we let A equal distance from first and let, I don't know, C, B, whatever, doesn't matter. Let's go with B. Let B equal distance from second. And no, that's not, sorry, D we already have. Oh man. Let D equal distance from second. And note that we have this right triangle here. So A squared plus the distance between the bases, which is 4, has got to be equal to D squared. So if you take the derivative of both sides of this equation, you get 2A A prime equals, this is 0, 2D D prime. In other words, you get that D prime is equal to 2A A prime over 2D. If you cancel out the 2's, you get that it's A prime over D. So all we got to do is figure out what A is, what D is, and what A prime is. A is my distance from first. So the distance from first at this point that I'm talking about is 3. A prime is the change in my distance from first. The change in my distance from first is -2. The speed I'm running towards first base, it's getting smaller, so it's a negative. And D would be my distance from second at this point that I'm talking about. So at this point that I'm talking about, I'm 3 away from first. I have this 3, 4, 5 right triangle. D is equal to 5. If you have trouble figuring out why D is equal to 5, D squared is 3 squared plus 4 squared. So D squared is 25. D equals 5. So what I get is that d prime is -6/5. If you leave it like this, I'm probably fine. I am fine. Or, really what I'm saying is that my distance from second is decreasing at a rate of -6, or I guess if it's decreasing, this is positive, at a rate of 6/5 Bryans per second. Either of these, totally fine. So I'll put a big box around both of them. Call it good. Call it the end of this quiz.